Morning, everybody. My name is Colin. I'm the president of the Biomedical Engineering Design team here at UVic, and today I'll be walking you through two of our projects, plus showing you how we've been getting them done through the pandemic. Before I get into the technical stuff, just a quick disclaimer that everyone you see on campus today is cleared for work via a safe work plan, and mostly works at the school as research assistants or research associates. And don't forget to ask me any questions along the way. An important part of biomedical engineering research is testing with human bone, but that process is very expensive and very difficult to recreate. And so one of our projects this semester is to create accurate human bone models with a modified 3D printer. Currently, this 3D printer just prints plastic like most other ones, but I'll show you what we have in mind to replace this with later. Printing plastic's not so bad though, and we can, of course, control it remotely using our Discord server. I'm going to do our remote 3D printing demo after lunch, but I thought it'd be more fun for you guys to pick what we 3D print. I've got a rather colorful presentation coming up in a second, but I saw that a heart had won on the story, and so I've set that up to the printer remotely. You can see I'm in a different space, but we're still controlling it from down here, which is really good for distance learning. 3D printing with plastic is great, and there's lots of printers that'll do that, but it doesn't really simulate trabecular bone very well. So in a second here, I'm going to show you one of the ways we've been mixing chemicals in precise ratios to more accurately model trabecular bone. That's the stuff on the inside of your bone. So to accurately model the bone, we need to vary the density throughout the structure. One of the ways we can do that is with a chip like this, where we inject two fluids that react together to form a solid slurry, vary the amount of air that goes into them, and that'll change the bubble size, which will overall change the density. So in order to get that level of detail on the chip mold here, the negative mold we use, we couldn't use a normal 3D printer. We had to use the fancy one here, which uses a laser and some chemicals in order to get a resolution of up to 25 microns. You can see the detail on these hearts here. So not only is our printer remotely accessible, it's actually integrated with our Discord server. And so you can see I have a little notification that our heart's done printing. Let's go take a look at. I've shown you a lot of content today from our printhead project, but we have another project, a wheelchair assistive device project, which is an addition to a wheelchair to help people carry groceries and other heavy items. Now, it really highlights some of the advantages of being part of the University of Victoria for this. We're exposed to a lot of feedback and a lot of involvement with the community. So I'm going to show you some footage from a design review we did with an engineering professor today, as well as some photos from a trip to a local hospital where we got even more feedback. All right, thanks everyone for following along. I hope you found it interesting and informative. I had a great time showing you around. If you want to stay tuned with more updates from BMed, you can follow us here. And engineering undergrads, feel free to shoot us a message if you're interested in joining.